And if the worst version of this story begins, most people will not recognize it at first. That is the terrifying part. A real solar disaster would not begin with some cinematic explosion over a city. There would be no giant wave on the horizon, no sirens that clearly tell the world what is happening, no single moment when everyone looks up and understands. It would begin quietly. A signal drops, a route changes, a control room gets tense, a transformer starts running hotter than it should, an aircraft switches communication mode, a satellite enters safe mode, a grid operator sees a pattern in the data that is not supposed to be there. And for most people, life would still look normal. That is what makes a geomagnetic crisis so psychologically disturbing. It does not arrive like a storm you can see. It arrives through the hidden systems of the modern world. Your source material makes this clear again and again. The true danger is not that the sky looks strange, but that the systems underneath ordinary life begin to fail in layers, especially if transformers are damaged and outages become prolonged. So let's imagine the version of events that forecasters do not want to name out loud, not because it is certain, not because it is even the most likely outcome, but because it is the outcome that explains why AR4366 matters so much. A major CME launches while the sunspot is in near-perfect Earth alignment. It arrives fast. Its magnetic field turns strongly southward. The storm intensifies beyond the kind of minor watch that sounds harmless on paper. The first impacts spread through the magnetosphere, and then Earth begins to feel it. At first, the effects are subtle. Radio operators notice growing noise and fading. Some long-distance HF paths become unreliable. Aviation planners start avoiding certain routes or leaning harder on backup systems. Satellite controllers begin monitoring anomalies more aggressively. Grid operators see geomagnetically induced currents beginning to move through the network. Nothing in that phase looks like collapse. It looks like stress. But that is how collapses begin. Your source material describes this exact distinction. Flare-driven radio blackouts are immediate and often shorter, but CME-driven geomagnetic disturbances can degrade communication quality for days, causing fading, dropouts, increased error rates, and prolonged ionospheric instability while the magnetosphere remains disturbed. Then comes the first real threshold. The grid begins to lose margin. That phrase matters, because infrastructure usually does not fail the moment stress begins. It fails when backup capacity, timing, and coordination begin to run out. A transformer takes on more direct current than it was designed to handle. Magnetic saturation begins. Reactive power demand rises. Waveforms distort. Protective systems respond. Operators reroute loads. Other equipment takes more stress. The network becomes less stable, not all at once, but piece by piece. This is where a multi-day event becomes more dangerous than a brief one. Your source file is very clear on that point. Even if portions of the grid could be restarted, a storm that is still ongoing would keep driving GICs back into the system. The danger is not just the initial hit. It is the inability to restore normal function while the magnetic assault continues. And if transformers are seriously damaged, the meaning of time changes. A power outage from a storm on Earth is usually measured in hours, maybe days. Crews repair lines, equipment gets replaced, power returns. That is not how a transformer crisis works. Large transformers are not waiting in storage for instant replacement. They are specialized, massive, slow to build, slow to move, and slow to install. Your source material states that a truly extreme event could mean prolonged outages lasting months or even years in the worst-hit regions, because the grid was never built for simultaneous widespread failure of critical transformers. That is when the story stops being technical, because once the power stays off long enough, every other system starts revealing what it depends on. Hour 1. Most people think it is temporary. Lights go out, signals weaken, internet becomes unreliable in places. Cell service starts degrading as backup power begins taking over at towers and switching centers. Most people expect restoration soon, because that is what experience has trained them to expect. Hour 3. The outage begins to feel wrong. Traffic systems fail in wider areas. Elevators stop. Some stores close immediately. Fuel pumps begin failing where backup systems are limited. ATMs and payment systems become unreliable. People reach for phones, only to discover that connectivity is weaker, slower, or missing altogether. Hour 6. The first serious asymmetry appears. Places with generators still function. Places without them begin to slide. Hospitals switch to backup power. Emergency centers prioritize fuel. Airports and traffic control systems begin operating in constrained modes. Some data services remain alive. Others begin to fragment. People stop asking, "Why is the power out?" and start asking, "How wide is this?" Hour 12. The refrigeration problem begins. Homes warm. Freezers start becoming clocks. Restaurants lose inventory. Pharmacies begin making triage decisions around temperature-sensitive medicine. Warehouses and cold chain logistics feel pressure. At the same time, water systems become part of the story. Your source material explicitly points out that in prolonged blackout conditions, water treatment and pumping systems begin to fail, which means the crisis stops being about convenience and starts becoming about sanitation, health, and urban survival. Day 1. Public understanding lags behind reality. That is one of the most important features of a systemic failure. People do not experience the whole picture. They experience fragments. One family sees no power. Another sees weak service but still has water. A hospital has generator power but growing fuel concerns. A port loses reliable communications. A remote aircraft route changes procedures. A neighborhood thinks this is just a local outage while the grid itself is under regional stress. Meanwhile, operators know something much larger is wrong because they are seeing the pattern. Communications degradation, satellite stress, GPS instability, voltage irregularities, reactive power issues, equipment alarms, and a source region on the sun that may still not be done. That last part is what makes AR4366 uniquely frightening. Your source material repeatedly stresses that the nightmare is not one isolated hit, but a sequence. One storm arriving while the active region is still capable of launching another, with continued X-class flare probability and the possibility of multiple days of cumulative stress. Day 2. Supply chains begin to separate into what still moves and what no longer can. Fuel becomes harder to access, not because it does not exist, but because distribution depends on electricity, networks, timing, routing, and functioning communications. Deliveries slow, warehouses struggle, traffic signals remain compromised, GPS timing and navigation issues complicate movement, ports, air corridors, and routing systems operate with less certainty. This is the part modern people often underestimate. Civilization does not break only when things are destroyed. It also breaks when coordination disappears. Your source text is blunt here. Communications, fuel, refrigeration, hospitals, supply chains, and water systems are all tied to electricity and network continuity. Once those start failing together, modern life does not end dramatically. It begins to stall everywhere at once. Day 3. Psychology becomes part of the infrastructure story, because by day 3, people are no longer dealing with an outage. They are dealing with uncertainty. How long will this last? Which systems still work? Can I travel? Can I pay? Can I get fuel? Can I reach family? Can a hospital stay powered? Can emergency services still coordinate if communications degrade further? And maybe the worst question, is the sun finished? Because that is what makes a geomagnetic event so different from a normal disaster. A hurricane passes, an earthquake ends, a wildfire moves, but a major solar active region can keep firing. That is why your source material describes the real nightmare as a storm sequence, not a single impact, one CME after another, one layer of stress stacking on top of the last, each one arriving before recovery is complete. Now imagine the more severe scenario from the file, not the moderate one, not the one with inconvenience and spectacular auroras. The stronger one, a direct hit CME, G4 or G5 intensity. Severe GPS degradation for days, HF radio unusable across broad regions, satellite operations significantly disrupted, regional grid failures spreading, economic losses in the billions, recovery measured in weeks. And then imagine the tail risk version beyond even that, transformers failing across multiple regions, tens of millions without power, satellite networks experiencing cascading problems, communication systems collapsing. The modern technological infrastructure pushed to its breaking point. This is the documentary climax of AR4366, not because we know that is what will happen, but because this is what the sun is capable of making possible, and that is the real lesson. We built a civilization so advanced that it feels permanent, a world of constant light, constant timing, constant communication, constant location, constant power, but those constants are not laws of nature, they are maintained conditions. And AR4366 is a reminder that those conditions sit beneath a star that can still interrupt them. That is why this is not just a story about solar physics. It is a story about dependence. Dependence on transformers no one thinks about. Dependence on timing systems no one sees. Dependence on communication layers most people never notice until they vanish. Dependence on satellites overhead. Dependence on calm space weather. Dependence on the hope that the sun does not choose this week to remind us what it can do. So if the world ever does live through a real multi-day solar outage, most people will remember it the wrong way. They will remember the darkness, the dead screens, the failed pumps, the weak signals, the empty shelves, the silence. But the real beginning will have happened much earlier, in places most people never saw, on the sun's surface, inside a tangled delta magnetic field, inside a transformer core, inside a control room, inside a line of telemetry from L1, inside a forecast discussion written in technical language that sounded calm right up until the moment it was. And maybe that is the most haunting part of all. A civilization can look stable, right up until the moment you discover what it was actually standing on. AR4366 is not just a sunspot. It is a warning written in plasma. A warning that the modern world is stronger than the past in almost every way. Except perhaps in the one way that matters most. We have more to lose when the sky turns against us. So after everything, the size, the flares, the radio blackouts, the CME forecasts, the transformer risk, the countdown window, the possibility of a multi-day outage, what are we really looking at? A scientific event? Yes. A space weather emergency? Possibly. But more than anything, we are looking at a mirror. Because stories like AR4366 do something rare. They do not just show us the power of nature. They show us the shape of our dependence. For most of human history, a violent event on the sun would have been a mystery in the sky, an aurora too far south, a compass behaving strangely, a night that looked wrong, a superstition. A warning people could feel but not explain. But today, we live inside systems so sensitive, so synchronized, and so invisible that a solar event no longer needs to be seen to be felt. It can move through radio, through satellites, through transformers, through grids, through GPS timing, through communications, through the quiet assumptions of everyday life. That is what makes AR4366 feel bigger than a sunspot. It is not just active, it is revealing. It is revealing how many layers of modern life depend on calm skies in ways most people never have to think about. It is revealing how vulnerable electrical infrastructure can become when geomagnetic currents enter the system. And it is revealing something your source material keeps returning to again and again. The modern grid was built for storms on Earth, not for a magnetic storm from space powerful enough to push direct current into transmission systems and damage transformers from the inside out. And that may be the most uncomfortable truth in the entire documentary, not that the sun is dangerous. We already know that. The uncomfortable truth is that our civilization is structured around the assumption that the danger usually stays at a manageable distance. Most days it does. Most days, the sun warms crops, powers climate, lights oceans, and quietly sustains the conditions that make civilization possible. Most days, it behaves like the stable center of our world. But that is not the whole truth. The sun is not peaceful. It is controlled violence. A star held together by gravity, pressure, magnetism, and continuous nuclear fire. A star that creates life by being violent in exactly the right way most of the time. And every so often, a star like that reminds the worlds orbiting it that life under a star is not the same thing as control over it. That is AR4366, a reminder, a dark, tangled magnetic wound on the surface of the sun, a region already producing repeated major flares. A region with a beta-gamma-delta magnetic configuration, the most unstable class forecasters use, and still growing more complex rather than settling down. And that detail matters because the fear in this story has never been about one dramatic image. It has always been about sequence. One flare is dramatic. A sequence of X-class flares is a pattern. One CME is concerning. A sequence of eruptions from a still-active region becomes something else entirely. That is why the file's scenario structure is so powerful. The middle path remains plausible. Repeated M-class and X-class activity, intermittent blackouts, GPS degradation, minor to moderate storms, noticeable but not catastrophic disruption. But the file is equally clear that the more dangerous paths cannot be dismissed, including a direct hit major CME with G4 or G5 consequences, and even a low-probability Carrington scale outcome involving severe transformer failures, satellite cascading effects, unusable GPS, and prolonged outages affecting tens of millions. That is the tension we end with, not certainty, not panic, but a narrowing space between the ordinary and the unthinkable, because that is where the modern world is most fragile, not in the disasters we already understand, but in the ones we understand just well enough to know they are possible, and not well enough to know exactly when they cross the line. That is where AR4366 lives in this story, right on that edge. And maybe that is why it feels so cinematic, because it is not simply about the sun doing something violent. It is about a civilization waiting for telemetry, waiting for updated forecasts, waiting for the next flare, waiting for the magnetic field orientation, waiting to learn whether the first storm watch was the main event or only the opening scene. As your file points out, the initial G1 watch is tied to the earlier CME, but the deeper concern is what AR4366 could launch next as it moves into stronger Earth-facing alignment. That waiting is what gives this story its final emotional weight, because waiting forces honesty. It forces operators to ask whether the grid has really been hardened enough. It forces forecasters to speak carefully even when the implications are unsettling. It forces engineers to admit that the system has never been tested at the level a true Carrington-class event would impose. And it forces ordinary people, once they understand the stakes, to realize that the world they experience as stable is actually maintained by networks that depend on conditions staying within tolerance. The power stays on because countless systems work together. The internet stays available because timing, routing, satellites, and electricity stay within margins. Fuel flows because pumps, control systems, and logistics remain synchronized. Water arrives because treatment plants and pressure systems remain energized. Hospitals function because the infrastructure under them keeps functioning. Modern civilization is not one machine, it is a choreography. And the danger of a major solar event is that it interrupts the choreography everywhere at once. That is why this documentary was never really about fear. It was about scale, the scale of the sun, the scale of our dependence. The scale of the illusion that because something is technologically advanced, it must also be invulnerable. AR4366 strips away that illusion. It shows that our greatest strength, interconnection, is also one of our greatest weaknesses. It shows that resilience is not the same thing as permanence. And it shows that the systems we rely on every hour of every day are stronger against ordinary failures than they are against rare, synchronized, space-driven stress. That is exactly the engineering reality your source material keeps underscoring when it talks about critical substations, transformer vulnerability, and prolonged outages in the worst-case scenario. So if AR4366 weakens, this documentary becomes a warning we were lucky enough not to need. If it misses, it becomes a lesson. If it glances past us, it becomes a story about how close a civilization can come to a stress test without fully entering it. But if it fires again, if the CME is faster, if the field turns southward, if the sequence intensifies, then this story may become something else. Not an analysis of risk, but a record of the moment the modern world discovered how exposed it really was. And maybe that is the final reason the Carrington comparison matters so much. Not because history repeats perfectly, not because every giant sunspot becomes catastrophe, but because Carrington remains proof that the sun's upper range is real. The star is capable of it, physics allows it, history remembers it. And the only real question is how the modern world would absorb it if that scale of event arrived now. That is the question AR4366 places back on the table, not as a theory, not as a textbook paragraph, but as a live possibility unfolding in real time. So when people remember this story, they may remember the giant sunspot, they may remember the X-class flares, they may remember the blackout maps and the CME watch and the fear of what might arrive next. But the deeper memory should be this: a civilization can feel permanent, right up until the moment it confronts the fact that permanence was never part of the design. We built for efficiency, we built for speed, we built for interconnection, we built for ordinary storms. We did not build for the sky itself to become the threat. And AR4366 is a reminder that the sky still can. So for now, the world watches. Scientists watch, operators watch, forecasters watch. And maybe after this documentary you watch too, because somewhere on the surface of the sun, inside a tangled field of magnetic stress, the next chapter may already be forming. And if it is, it will not ask whether we are ready. It will only test whether we ever. If you enjoyed this documentary, subscribe to the channel and turn on notifications for more deep dive stories on solar storms, black holes, cosmic disasters, ancient mysteries, and the hidden forces shaping our world. Because sometimes the biggest threats do not rise from the ground beneath us. Sometimes they begin in the sky above us.